All right, so we've got our function. There exists a c value. That's an x coordinate, just so we know. Here's our interval that satisfies the conclusion of the mean value theorem, which could be c. All right, so let's say, write down our mean value theorem formula here. All right, so I got to put the derivative here. So this is the function sine of x over 2. Remember that that's really just the same as sine of 1/2 x. It's better to probably write it like that. So I'm going to derive that. That would be a chain rule because there's more than an x inside here. So that's the derivative outside's cosine. Keep the inside. And then times by the derivative of the inside. All right. And then I have to plug in f of b. So that's 3 pi over 2 is my b value. I have to put it in right here. So that's going to be sine of, when I plug this in here, don't forget I also have that half. So that's going to be 3 pi over 4. That seems right. Minus, and then I plug in the pi over 2. So that's sine 3 pi, pi over 2 would be just pi over 4. All over 3 pi over 2 is the b minus pi over 2. All right, so now let's see if we can find these values for sine 3 pi over 4 and pi over 4. Well, I'll draw a little picture here. So pi over 4 would be we should know that that's a 45-degree triangle. So that's 1, 1, radical 2. So for this, it's 1 over rad 2. Sine is opposite over hypotenuse. And then 3 pi over 4 is of almost 1 pi. That would be to this quadrant. And then it would still be a 45-degree angle. And then it would be 1. This would be negative 1, rad 2. And then if I find the sine of this one, it would be opposite 1 over rad 2. So this is 1 over rad 2. All right, so that minus that is just going to be 0 on top. So I'm going to rewrite this formula again. But this time I just can catch that this minus this is just going to be 0 over the bottom. Doesn't matter because it's over 0. We got 0 here. So now I need to solve this. So I'm going to first multiply 2 to the other side. 2 to the other side is just going to be 0. So it's just cos 1/2 x equals 0. And then I need to find when cosine equals 0. And here's what I'm going to do, just play around with this a little bit. This is going to change my period of cosine. Here's the iron condor for cosine. There's the shape. Normally it would go to 2 pi, but if it's a 1/2, it's going to take the x's and double it. It always, whenever you affect the x, you go twice as much, not half, but twice as much. So this is 4 pi. So right down the middle is 2 pi. This is 1 pi, 3 pi. So we're trying to find when will this equal 0, and that would happen at 1 pi and 3 pi. The answer here is just 1 pi. And the reason I wouldn't put 3 pi is because it's not even within the interval here. So pi is the answer then.